There are a few special percentiles, which we call quartiles, because they divide the data up into four intervals, each of which contains an equal number of data points. So the first quartile is basically the 25th percentile. They're the same thing. It's also abbreviated as Q1. So that's the point that separates the lower 25% of the data from the rest. Of course, the median is also known as the 50th percentile, or we could call that Q2. It usually isn't written that way, but we could think about it as the second quartile. The third quartile, abbreviated as Q3, is also known as the 75th percentile. So it separates the top 25% of the scores from the rest. So thinking about it this way, the central half of the data points are between the first quartile and the third quartile. That's a really good way to define the heart of the data, the central half. So we're going to use how to learn how to generate these numbers, as well as produce a really nice graph of them, which we call the box plot. So StatCrunch actually generates what's called a 5-number summary. And that would be the minimum, the first, second, and third quartiles, and then the maximum, 5 numbers altogether. For our illustration, let's use the data from the last example, which involved prison sentences. If you look at the column variable 1 here are those sentences ranging from 5 years to 15 years. And we can do a summary stats columns, select variable 1 for now. And then I'm going to go down here and select those 5 key numbers. And they're not listed in numeric order. But we're going to select the median, the minimum, maximum, first quartile, and third quartile. And here they are. Again, I really wish it would put them in order. I wish the minimum was on the left and the maximum was on the right, but that's how they're listed. We can also very easily generate a nice visual of these numbers. It's called the box and whisker plot. And we can do that by going to Graph, Boxplot, it's called on StatCrunch. And again, I'll just select variable 1 for now. It gives us a couple of options. I prefer to uncheck this one and check this one. And then I guess you can choose colors and all that good stuff. But for now, let's just compute it. Okay, so what we're looking at here is we have the number line on the x-axis. These are the prison sentences in years, ranging from a minimum of 5 to a maximum of 15. The box and whisker plot is drawn kind of floating above that x-axis, and the vertical axis has no meaning in this context because it's not measuring anything. But basically we use like vertical tick marks for these 5 numbers. So this one represents the minimum, which is above 5. And then we have our first quartile at 8, the median at 10.5, the third quartile at 12, and the maximum at 15. And then just as a visual aid, we enclose this heart of the data in a box between the first and third quartiles. And then that shows you where, again, the central half of the data is located. So we can generate 2 of these for 2 different sets of data, and I'd like to do that. Actually, let me come back to that in a minute. Let me address this IQR again. So the interquartile range is the width of this box. And we would calculate that by just subtracting the third quartile minus the first quartile. That's called the IQR, interquartile range. So do you think that would be more of a measure of center or a measure of variation or spread? I hope you're thinking that the IQR is a measure of variation because it's not a central point, it's a width. It's the width of an important part of the data, right? So the interquartile range is another version of a measure of variation, just like the standard deviation or the range. We can generate that on StatCrunch as well. If we go to Stat, Summary Stats, Columns, Variable 1, and if we just select the IQR, that stands for Interquartile Range. We're expecting it to be 4 because that's calculated as 12 minus 8. And there we go. All right, the next thing I was going to do was to illustrate how you can draw 2 box plots for 2 different sets of data and how outliers affect the box plot. What I'm doing with the variable 2 column here is I've copied and pasted the first 20 data points, and then I've added a few outliers. So let's just suppose that in this set of data, someone was sentenced to 25 years in prison, and someone else to 40, and someone else to 60 for a very serious infraction, or a very angry judge or something. But let's see how we can compare these data sets one above the other. So if we go to Graph, Boxplot, and now we can select variables 1 and 2, and let's uncheck this and check that again. And now we see them situated one right above the other. They're both floating above the same common number line, so they're drawn to the same scale. So that gives us a nice, quick, and easy way to compare them. For example, here you can see that their cores, or their hearts of their data, predominantly overlap. So that part is pretty much preserved. But the key difference is that in the second set of data, we have this really long tail now, which represents a skew to the right with all these outliers on it. Now let's take a look at how these outliers affect the basic statistics. That would mean, for example, the mean or median, or the standard deviation, or the interquartile range. And the answers might surprise you a little bit, or maybe not. For example, if you look at the medians here, remember the median is the vertical line within the central box. And you can see that that actually hasn't shifted very much, right? Because we added a few data points on the far right end, but the center of the list is still basically in the same position. So we should expect that the median won't change very much. I guess this next one is the other easy question to answer. Do you think the standard deviation will get affected very much? And do you think the interquartile range will get affected very much? In other words, what difference do you see between this distribution and that one in their standard deviation versus in their interquartile range? The point that I'm making here is that the standard deviation is a little bit more related to the entire width of the data. So we would expect it to be quite a bit larger for variable 2. Whereas the interquartile range is only the width of the central box, and that appears to be pretty much the same. So let's calculate these numbers and see if we can corroborate our intuition. So if we go to Stat, Summary Stats, Columns, we're going to select variables 1 and 2 this time. And this time we will select mean, standard deviation, median, and interquartile range. And I think I can put them in the table this time. Okay, so it puts the data in funny places sometimes. I had to slide to the left to see the original data, but here are the summaries. They're way over here. Okay, so variable 1, the original list had a mean of about 10, but when we added those outliers to it, that list had a mean of about 14. So it grew by 40%. That's pretty significant. Compare that to the median. The median only shifted a little bit from 10.5 to 11. So the point here is that in the presence of outliers or skew, the median is more stable than the mean. We sometimes call that resistance. The median is resistant to outliers. And you'll see the same thing for the interquartile range. The interquartile range in this case didn't change at all. It's still 4, but the standard deviation got way, way, way distorted when we added those outliers. It grew from 3 to 12. So the IQR is more resistant to outliers than the standard deviation as measures of variation. So what's the moral of the story? The moral of the story is when we need to describe a data set with summaries, like a measure of center and a measure of variation, we should prefer the median and the interquartile range when there are outliers and or skew. Otherwise, if we're looking at a relatively symmetric data set, then the mean and standard deviation are usually preferred as defaults. Okay, so that's really what it comes down to, and you're going to be tested on that issue a little bit in your homeworks. That's what it comes down to. Okay, so let's come back to the outline and just kind of wrap things up here with a few pros and cons. Issue number 1 is basically comparing the pros and cons of box plots versus two-dimensional curves, like bell curves, for example, with a frequency axis. The box plot is a one-dimensional representation of the data. So it can be useful for quickly comparing 2 or more different distributions, like the ones we just laid on top of each other. But it does lose some information inherent in the two-dimensional shape of the distribution. Right? When we look at a box plot, we can't necessarily see if it's bell-shaped or skewed, or if it maybe has 2 modes, and we can't see exactly how high it peaks. So we lose that information. Second issue is the one we just discussed, that the median and interquartile range are preferable to the mean and standard deviation if the data is skewed and or has outliers. But otherwise, the mean and standard deviation are preferred defaults. Okay, at long last, I think that concludes our week 2 lectures. There's been a lot of material this week, a lot of important material this week. But after you've had a chance to digest this, then you should be ready to move on to your homework. And I think we've learned everything you need to nail those homework problems. So good luck with that, and I hope to see you soon.